Hard surface modeling is a 3D modeling technique that can be used to create objects with hard surfaces such as weapons, vehicles, machines, and other objects. It has become increasingly popular in the CG world. In this video, we get to know the basic principles of this technique, and all the things and tips that are needed for modeling this level can be stated. If you're modeling realistic cars or futuristic weapons, or even just starting out modeling chairs and furniture, mastering hard surface modeling is sure to take your skills to the next level. Your support makes us continue this series of videos. So support us with likes, comments, and subs. Hello, welcome to MIMViz. Let us start this topic with the most important related tool, Turbo Smooth. In order to be able to model complex shapes with this method, we must be familiar with the logic of this tool and understand it, and finally by adding it, we will increase the details of the model. To start the work, we create a plane, add and edit poly to it, and move the edge up from one side with the help of Shift. Then we copy it to check Turbo Smooth on them. Here we have two surfaces that are connected by an edge. We add Turbo Smooth, and we see that this modifier connects two edges by a curve. By increasing this number, the number of polygons can be increased and a smoother volume can be created. Now let's find out how and on what basis this curve is formed. We can see that there is another edge between these two edges, and basically, this middle edge has turned into a curve. The more the number of edges and the smaller the distance between them, the sharper the edge will be. Let us see it in an example. In the second model, we select the middle edge and chamfer it. You can see that our curve is narrower than the previous shape. So, the more the number of lines between them and the closer they are to each other, the sharper the edge. And this is the most important factor in this style of modeling. In the same way, in the next shape, we create a chamfer with a smaller number and we see that we get a sharp edge. In the front view, you can see all three modes and the collision of the turbo with the edges. For a better understanding of the edges, a standard material can be made and attributed to the dimensions. In this case, you can fully understand the difference with the help of specular. The second point we should pay attention to is that our modeling should be done with quadrilateral surfaces. The rest of the Turbo Smooth levels make mistakes and make the work difficult. Let's go to get acquainted with the rest of the techniques. We create a box with specific dimensions and give it Turbo Smooth. Well, here our box is completely turned into a sphere because every edge is turned into a curve. We take a copy of it and assign an edit poly to it, and delete the two side polygons. We turn on turbo and see that it creates a cylinder for us. Because here, we only have the edges in one direction, and naturally, the curves are formed in that direction, and we will have a completely healthy edge on the two side edges. Now, if we take another copy of the shape and take its edge and select them with the help of a ring and finally chamfer it, we will see that, with the addition of Turbo Smooth, the working edges become sharper and keep their shape. Next, we copy it again and create the chamfer with a smaller number to reduce the distance between the lines. In this case, Turbo Smooth creates the edges with the highest level of sharpness. If we attribute the material to it, we can see the difference in them more clearly with the help of specular. In the following, we can see and check the interaction of Turbo Smooth with triangular surfaces. We take a copy of this shape, and by giving an edit poly and removing two polygons, we attach this vertex to it with the help of target weld to create a triangular surface. Well, the triangular surface is created so that this sloping surface is created in our form. First, by turning on turbo, we have a soft shape, but we want the edges of this shape to be sharper, so we have to create lines on the edges, and this time we want to use Swift Loop. In this topology, the problem we have is that we cannot use Swift Loop. Let me explain about Swift Loop. This tool allows us to create a line along several lines that are parallel to each other. You can see that the create cannot create the line. To solve this problem, it is enough to create a Swift loop and extend it with the help of cut in the triangular space. By using constraint and edge mode, we can move the vertex in the direction of our lines. We align it with the rest of the vertices. Let's see the result of turbo work here to continue working. We take these edges a little lower. We also inset the lower level to create a line. You can see the result of Turbo Smooth after doing these things. We do the same with the upper edge. You can see the result of creating a form with sharp edges. In principle, Turbo Smooth can also have a triangular surface, but it definitely has some problems. From here, you can have Swift Loop in this volume as well. In the following, we will learn more techniques. We create a plane and assign an edit poly to it, and create a line in the middle of it. Add a turbo smooth and extrude the created line to see the result. You can see that increasing the height and width can get different results. In general, it is better to use chamfer and surface extrusion instead of extruding a line. In this way, we will have a better topology. In general, we should have seen the result of extrusion. We take a copy of the plane and delete the previous layers and add a new edit poly. With the help of connect and chamfer, we get the desired result. Next, we lower the created surface with the extrude and erase the two extra surfaces. With the help of another edit poly, we chamfer the edges of the gap to check the different results. You can see that the edges of the gap are quite sharp. By turning off this layer, you can get another result. Next, we get help from a box. Select the surface on the box and inset it. Here, we want to see the reaction of the turbo to the curved lines. We extrude the created surface by taking Shift down. Now you can see the result. It is quite clear that these lines cause the volume to curve in this direction. That is, curving is done in both directions. We will take a copy of the shape to check another mode. Let's clear the bottom part of the shape so it can be seen better. With the help of cut, we draw the lines you see. Now, we align the vertices. One of the lines remained, which we will also correct. Now, we can delete the corner lines. You can see the difference in both cases. The angled lines were aligned and formed a curve with the addition of the turbo, but here the edges remained exactly as before. I think you understand the importance of the topology of the surfaces. Sharp edges can be created by adding a chamfer. By playing with numbers, you can see and create different results. You can see how clean our circle is. We take a copy of the previous state and put several copies of the element together. By turning on Turbo Smooth, you can see that the volume is damaged. By welding the vertices in the middle, you can see that the effect of the angular lines disappears, and we will have a healthy volume there, and we only have curves in the corners. Here too, the edges can be chamfered in 2 steps. Well, let's go to the last topic today to finish the basic topic. In this case, we want to create a circular hole in this cubic form. First, with Connect, we create lines in the center of the volume to create a vertex in the center. Now by chamfering it and playing with numbers, we reach the desired circle. Pay attention that the more the number of sides, the better the circle, but we create a fuzzy topology. So let's try to use optimal numbers. After creating it, depending on the form we want, we need to cut these vertices to the sides to form a quadrilateral topology. First, we use a small number and remove the middle polygon, and now we can see the result, which does not have a very correct form. So we take another copy and first chamfer its edges. We cut the connections and finally chamfer the vertex with more number. We erase the polygons in the middle and see the result that the corners have problems. We create the lines with the help of Swift Loop and finally connect the vertices with Cut. You can see the attractive result by turning on Turbo Smooth. Compared to the previous shape, you can see how much better the shape is, even if we chamfer the edges of the previous shape. A better shape can be created by arranging vernicas, but you can use symmetry here for higher speed to create relative shape. You can also create an n-gon as a reference and create lines from it, and build your own shape topology. If we want to make a conclusion, this method of modeling is very simple, and it is enough for you to understand its logic and achieve the desired result by creating lines in the right place. Order is very important in this method of modeling. The use of quadrilateral polygons and the distance between the lines are also important. In this video, the basic principles of hard surface modeling were discussed. In future videos, we will do exercises such as chair modeling, car tires, and complex models. Support us with like, comment, and sub. Bye until the next video.